Greetings and welcome back to part 6 on the video series on trend lines and regression analysis. In this particular video, we will look at regression with categorical variables. Some data of interest in a regression study may be ordinal or nominal data, such as demographic data, or male-female, for example. Regression analysis requires numerical data. Therefore, if we want to include categorical data as independent variables, then we must code these categorical data numerically using dummy variables. For variables with two categories, you can code them as 0 and 1. So let's look at example here. Let's say, this is an example on employee salaries data. And in this particular data set, there are 35 employees. To predict salary using age and MBA, whether the employees have MBA or not, we can, if we want to develop a regression model, we now have to code the MBA. We can code it as, if it's a yes, it is a 1. If it's a no, it is a 0. So we will then use the model to develop an equation, and we find that salary is equals to 893.59 plus 1044.15 multiplied with age plus 14,767.23 multiplied by MBA. If MBA is equals to 0, salary is equals to 893.59 plus 1044 multiplied by age. If the employee have an MBA equals to 1, salary is now 15,660.82 plus 1044 multiplied with age. The only difference between these two equations is in the intercept. So the model suggests that the rate of salary increase for age is the same for both groups. Of course, this may not be true. Individuals with MBA might earn relatively higher salaries as they get older. In other words, the slope of age may depend on the value of MBA. Next, we want to look at interactions. An interaction occurs when the effect of one variable is dependent on another variable. We can test for interactions by defining a new variable as the product of two variables. Let's say x3 equals to x of 1 multiplied with x of 2. And testing whether this variable is significant, leading to an alternative model. So we have y equals to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. So this is your new variable plus epsilon. So now let's look at the example. Where we want to define an interaction between age and MBA, and then we rerun the regression. So earlier we have the age and MBA, and then we calculate our regression. So from this data, from this table, we can see that the MBA indicator is not significant. Therefore what we can do is we can drop and rerun this again. When we rerun the model, we can see that the adjusted R-square has increased slightly. Prior to this, the adjusted R-square value is 0.97670, and now it is 0.976723. It's very slight increase, and both age and model and both age and the interaction terms are significant. Therefore we can say that the final model is salary equals to 3,323.11 plus 984.25 multiplied by age plus 425.58 multiply with MBA multiply with H. Because this, remember, our interaction variable is MBA multiply with H. Okay. So when a categorical variable has only two levels, okay, as in the previous example, we code the level as 0 and 1, okay, and added a new variable to the model. However, when the categorical variable has k greater than two levels, now we need to add k minus 1 additional variables to the model. Okay, let's look at an example. Okay, this is an example on surface finish data. And in this particular data set, it provides a measurement of the surface finish of 35 parts produced on a lathe, along with the revolutions per minute of the spindle and one of 4 types of cutting tools used. Okay, so if you look here at this particular table, we have cutting tools. So we have cutting tools A, B. Okay, 4 types, so we will have A, B, C, and D. Okay, so because we have K equals to 4 levels of tools, okay, see, you have B, C, and D. We will now refine a regression model, okay, of the form beta naught plus beta 1x1 plus beta 2x2 plus beta 3x3 plus beta 4x4 plus epsilon. Okay, where y is our surface finish, okay, our dependent variable. Beta naught is the intercept, okay. X1 is your RPM. X2, if, okay, it will be 1 if the tool type is B and 0 if it's not. X3 will be 1 if the tool type is C and 0 if it's not. Okay, X4 will be 1 if the tool type is D and 0 if it's not. Okay, so what about A? Okay, A will be when X2 equals to 0, X3 equals to 0, and X4 equals to 0. That means by default, the tool type is A. Okay, so when we run the regression, okay, this is our results, and then we can write down our equation. Surface finish equals to 24.49 plus 0.098 RPM minus 13.31 of type B minus 20.49 of type C minus 26.04 of type D. Okay, so we look at our coefficients, okay, and we write down our equations.